This example for me is fascinating because this is a true real-life example of where geometric sequences are used in things that you've probably used. Most of you have gotten something like, I had a headache once, or you got sick and you had to go get antibiotics. Now, the way that a drug works in your system, for most drugs, is that you take a pill, but then after a certain amount of time, your body has used up most of that medication, and then your doctor says you're able to take another pill after 8 hours or once a day or something like that. So here's someone who has a chest infection, okay? They get tablets, and those tablets contain 500 milligrams of some sort of antibiotic drug, okay? Each time that you take a tablet, your body, so the doctor gives you a certain amount of time. That has all been calculated mathematically for a reason, right? If you have a chest infection and they give you 50 pills, not a good idea, like, I want to get rid of it right away. I'll just eat all 50, okay? You've learned over time that that's not a good idea. That could cause a lot of stress on your body, could cause it to go into, all sorts of things that aren't good. So you have a schedule, okay? That schedule here looks like this. You take 500 milligrams, it doesn't get rid of your chest infection. The next time you take another 500. So if you just took one tablet, you'd have 500 milligrams. If you took a second tablet, does it make sense that when you take the second tablet, so now this 500 is my second tablet, there's still going to be a little bit left from the first one? It says here that 15% is left after you've taken the first one. So if I do 15% of 500, that's how much would be left. We could calculate that. Now, if I had to take a third tablet, now this is my first tablet, this is my third tablet. My second tablet would be reduced by 15%. My first tablet would be reduced by 15% twice. Does that make sense? That when you're on your third tablet, the tablet that you took one time ago, now only 15% of that is, and the tablet you took 2 times ago, 15% got taken off once, and now 15% is left again, so that becomes 15% happened twice. And this makes a geometric series. If you added a fourth tablet, the third tablet would be reduced. The second tablet would be reduced. The first tablet would be reduced even more. And if your body is always leaving a little bit left, this also explains how they do drug tests for the Olympics. Even though you've taken a drug and it was a long time ago, right? You didn't think it would still be, it's still a trace of it's left in your body. And they can trace it back to say, if we did the drug test 3 days after your race and you have this drug in you, that means when the race happened, you had this much of the drug in your body, and it was doing this to help you enhance your performance. So this is also important. It's not like, oh, I'll just drink more water and it will go away. That doesn't happen. Your body uses it up, but a trace of it always stays in there. So now if, right, in part A, right, how much is after each of these? 3 tablets. You might use, we wrote it out, you might use middle school math to figure this out. If I wanted to add up those 3 tablets, I could just type that into my calculator, 500 plus 0.15 times 500 plus 0.15 squared times 500. 586.25. So after 3 tablets, when you just take your third tablet, you would have 586.25 milligrams. If you went to 10 tablets, now you might want to go to your formula. Okay? This is 1 tablet, 2 tablets, 3 tablets, so the sum of the first 10. Do I know term 1? Yes. 500. 1 minus. Do I know R? I am multiplying by 0.15 each time to the exponent of 10 over 1 minus 0.15. So I go to my calculator, type this in exactly like I see it. 500 times 1 minus 0.15 to the exponent of 10 divided by 1 minus 0.15. 588.24. And what is fascinating about this, and it's mathematically figured out for most drugs that you take, like Tylenol and whatever, like common ones that you need for headache, that even if I did the sum of 100, if I did a sum of 100, you see that the only number that would change would be this 10 would change to 100. Check it out. Would you have you'd be taking this drug, like if this is a once-a-day drug, you've been taking the drug for 100 days in a row. Okay? So part of the concern, would you have a ton of that drug in your body? Well, if I just retype this and just change the 10 to 100 and push enter, how much did the number change? Almost nothing. You see, just way down at the decimal places, it changed. At a certain point, the 15% that remains is always if I take 15% of 588, it'll be almost exactly 500. And if I take away 500 and I add 500, because each time I take a pill I add 500, I'm back to 588. Then the body takes away 500, you add 500, and drugs are designed this way to reach an equilibrium that your body can handle. And they're also designed to reach an equilibrium that's higher than the first dose so that you don't shock your body the first time, right? If you took too many Tylenol for your headache at the beginning, your body might also react in other ways, like, what is this in my body? I don't like this. And you're like, I don't know if you get shaky from Tylenol. Right? You can get shaky from caffeine, right? If you have too much caffeine all in a row. Right? Those in-service days when I bring my own coffee, and then they bring the Tim Hortons coffee in, and then all of a sudden I'm like, whew. Okay. So it's designed that way, which is really cool to see it from that mathematical perspective. Okay, so with this, we are now done section 1.4. The last question to circle from the homework is number 12. And we'll take the last 10 minutes to work on those questions